Yeah, we are solving a problem from current electricity. The problem goes like this. There is a wire of resistance 4 ohms and is used to wind around a coil of radius 7 centimeters. So let us try to understand the problem by writing down the data. There is a coil. Let us say this is the coil in a circular shape. This coil is having a radius, that's the diameter, of course. So radius of the coil is given to us in the problem, that is 7 centimeters. I will convert them into SI system. 7 into 10 power minus 2 meter. Around this coil a wire is wound. So let us take a wire. A wire is wound around it like this, right? Resistance of that wire is given for you. Resistance of that wire wound around the coil is 4 ohms. This wire is wound around this wire. I'm talking about this wire. That's also having a circular cross section. That has a diameter. So this is, be careful. What is talking about the diameter is not the resistance, not the diameter of the coil, rather it is the diameter of this wire. Diameter of wire is 1.4 millimeter, that is 1.4 into 10 power minus 3 meter. That implies radius of that wire is half of it, 0.7 into 10 power minus 3 meter. So be careful. This is the radius of the coil, whereas this is the radius of the wire. They are quite different. Yeah. Resistivity of that wire is also given for you. Resistivity is a way of measuring opposition to the flow of current to any wire. Resistivity of that wire is given to us in the problem. I am just taking down all the data that is given to us in the problem. Then the question is, how many number of the turns that the coil is the question that it is, right? Now as the resistance is given for you, we know there is a relation between resistance and resistivity for any wire. The relation is R equal to rho L by A. R is resistance, rho is specific resistance, L is length, A is the area of cross section of that wire. Now resistance is known for you, rho. L is the length of the wire. As the wire is wound in a circular form, length becomes 2 pi into radius of that coil. Why radius of the coil? Because wire is wound around the coil. If it is one turn, but there are n number of the turns wound around the coil, therefore I am writing it like 2 pi radius of the coil into n by area of the cross section of the wire, that is pi radius of the wire. Be careful. This is radius of the coil because that's wound around the coil. This is the area of the wire, that's why radius of the wire has to be written pi r square. Now we were asked to find out how many number of the turns are there. Let's just keep n there on the right side, get everything else to the left side. So resistance, this pi and pi can be cancelled. Radius of the wire square by rho, this 2 into radius of the coil. That's how I need to get into a formula to find what is being asked in the problem. Now all the data is available for you readily. We just need to substitute them. Let's try to substitute. Number of the turns is resistance, which is being given in our problem as 4 ohms. Radius of the wire square. Radius of the wire is 0.7 into 10 power minus 3 whole square divided by resistance. Resistivity is given for you 2 into 10 power minus 7 multiplied by radius of the wire square, radius of the coil. What's the radius of the coil given for us is something like this one, 7 into 10 power minus 2. Let's try to simplify this, right? Here is a row, of course. There is a 2 that I have forgotten to write here. Into 2 is there. Row 2 is there. I have written that 2. This 2 is nothing but its resistivity. So this 2 into 2, 4, and 4 can be cancelled. So what's the number of the turns remaining? 0.7 square, 0.49, 10 power whole square, 10 power minus 6, 7, and 10 power minus 2, 10 power minus 9. This I can write it as 49 into 10 power minus 8 by 7 into 10 power minus 9. This is 7 plus 1, that is 70. That means the wire is made a number of turns 70. That's what he is intended to find. It's a number, therefore it has no units and dimensions. That's it. Thank you.